Good morning. How's everybody doing this morning? I like to have interactive presentations, so we're going to start off with some practice. Is it okay if I move around? Can everyone still see the screen and everything? Okay. How's lunch? Okay. All right. That's about what I expected. My name is Kevin Porman. I am a developer evangelist here at Salesforce. That was my email address. You'll see it again here. A little bit easier to read. And when I was a little kid, I loved getting mail, postcards in the mail. I grew up, and now all I get in the mail are bills, so please don't send me anything in the mail, but please follow me on Twitter. Let me know how the session was. I especially enjoy snide remarks. All right? So we're going to talk about, first we're going to talk about the forward-looking statement. Since I am a Salesforce employee, I get to throw this wall of text up at you and remind you that as a customer of Salesforce, you should make your purchasing decisions based only on what is publicly available and not anything that I might talk about coming in the future, the bright, shining future. I'm not planning on talking about anything in the bright, shining future, though, so. All right, here we go. So what are we going to talk about today? We're going to talk a little bit about what a unit test is. We're going to talk about why people don't write unit tests. We're going to talk about why you should write unit tests. And there's going to be a little bit of a math quiz in there. We're going to talk about how to write good unit tests, and then we've got questions and answers. And the way I do the questions and answers is, if nobody has questions for me, I'll start asking you questions again. All right? Sound fair? Oh, we've lost the participation thing. Everybody's eating lunch. Does that sound good? All right, we got one guy in the back here. All right, so what is a unit test? A unit test can be defined in, I looked it up, there was like 179 different definitions in the first 10 pages of Google. But my definition is, it's additional code that you write that runs your code with known inputs and expects certain results out of your code. Does that make sense? Known input, run your code, expected output. So if we had a math method called add, we would say that add with the parameters 2 plus 2 should equal 4. 4. All right, very good. So that's a positive unit test. We're going to put in good information. We're going to expect to get a valid result in the end. So we're going to go over some reasons people don't write unit tests. Why do developers not write unit tests? And we're going to sort of debunk them Mythbuster style here. First reason, the reason people don't write unit tests is they don't know when to write them. And I found this actually interesting. I did a little bit of a poll among some of my developer friends about why they've heard people don't write tests. And the first one that came up on there was they don't know when. And I thought, when? What do you mean when? And they said, well, some people come back and they go to workshops or they go to a conference and they hear you should write your unit tests and then write your code and let the unit test tell you how to write your code. And then they read blogs or best practice books or what have you, and they come up and they say, no, you should write your code and then write your unit tests. And over here, I'm scratching my head going, I don't think it matters. Just write the unit tests, right? So why don't people test? Sometimes they don't know when. As long as you write the unit tests, you're good in my book. All right? No judgments here. I've done both. And I think the truth of the matter is, as you start to write unit tests, you'll find that you're reflexively going back and forth between the tests and the code. You're going to write a test. It's going to fail. You'll change something in your code. It'll work. You come back later, maybe later that day, maybe later tomorrow, and you come back and you say, okay, I'm going to change my code. And then you're like, oh, well, I need to change my test too. So it's about going back and forth, not one or the other. This is my favorite one. Has anybody ever heard, that's not my job? I don't write unit tests because that's not my job. Right? All right, so there was a whole bunch of survey responses, and it's not my job. I've got QE engineers for that. I've got QA engineers for that. That's what users are for. A bunch of other different responses in that same vein. And the idea here is they're saying, oh, well, that kind of testing isn't my job. It is. There's lots of different kinds of testing. And your QE, your QA, they're probably doing functional testing. If I click this, what happens? That's not a unit test. We're talking about unit tests here. Unit test is your code tested by other bits of code with known inputs expecting expected results, right? A QE or QA engineer, they may write some unit tests, but that's not their job. They're doing functional tests. They're doing integration tests. As a software developer, it's our job to write unit tests for our code. Some people say, oh, I don't write tests because it takes too long. And some people who say this aren't developers. Have you ever had a manager say, oh, it takes too long to write unit tests? I got one guy back here. He's my favorite developer in the crowd. He's raised his hand on a number of questions here. So I had a manager of mine explain to me that we're not going to write unit tests because they can take a whole lot more time. And it's true. Studies have shown that on average, a project that has no unit tests will be completed 30% faster than a project with unit tests. And that's true. That's empirically true. Study after study has shown this. It's also one of those alternative facts where it's true on the surface, but as soon as you start digging into it, it sort of crumbles and you go, wait a minute. So I got a study source there. I'll leave that to you to read. It's a big one. The big study shows that tests reduce the number of production bugs anywhere between 40 and 80%. And that is a big number, a big range there. So I did a little bit more testing. There's a whole bunch of studies, and they all show between 42% and 79.5%. So forgive me for the 0.5%. Right? We're going to do some math here in a little bit, and we're going to use 60% as an average. Okay? So they reduce the level of production bugs. And why does that matter? Well, it matters and why you should test because of math. IBM did a study about 2010, 2012, and they put some numbers on this. We're going to use simple math, 100, 650, 1500, and 10,000, about how much it costs to fix a bug depending on where you find it. So if your user calls you up and says, hey, I can't complete my order because of something, that costs you a whole lot more money, not only in opportunity loss, but in fixing the bug than it would if you found it in design on paper. So as you're working out the engineering and architecture of your system, fixing a bug there costs $100, right? Now, if we find it in the practice of coding, as we're writing our unit tests, we might fix that bug, and because we're writing unit tests, because we're taking a little bit longer, that might be $650. If you capture it in acceptance testing, if your QA engineer, your QE engineer comes back and says, hey, I was trying to do this and it didn't quite work, but it hasn't gotten to production yet, it's going to cost you $1,500 to fix. And finally, if you catch it in production, that's 10 grand, not mentioning any orders you might have lost because of that bug. Why you should test? First off, it makes dollars and cents, right? Now, let's do some math work here. We've got a team of 4 people, 4 developers, and we're going to let them work on a software project for an entire year. Now, if you subtract a fairly basic vacation package, standard holidays, a couple of sick days in there, you're looking at about 43 weeks of work for the team total. Okay? Average of 6,860 hours. Now, if we take those, and that's for, I'm sorry, let me back up here. This is an important part. This is without tests. Project going to be a year long, no tests, 6,860 hours, 43 work weeks. Now, if we switch over and we start doing the unit testing, we got to add 30% more, right? 30% more, we're going to add 2,058 hours, and that's basically another head count. That's basically another person. So yeah, it's true. It takes longer. It takes more work to do unit testing. But here we're going to do this. We're going to do it 56 weeks, a little bit more than a year. And when we get done with that, we're going to look back over our year and we're going to say our team was pretty active and they averaged amongst themselves 1,000 lines of code every day. It's not bad. Now, if we take a look at another research paper, this one from Microsoft in their book Code Complete, they've got a book, they went through this and they said, okay, on average, for our products, you're going to have between 10 and 20 bugs, defects of all ranges of severity, but between 10 and 20 per 1,000 lines of code. So if we keep doing the math here, let's say 15 bugs per 1,000 lines of code, we're looking at about 645 bugs. That's almost $6.5 million to fix all of those in production for a year-long project. Now, I don't know about your boss, but if I went to my boss and I said, hey, we're going to implement this program and we're going to capture 40 to 60% of our bugs before they get to production, and we think that's going to save a whole bunch of money, well, we can put some math on it and say that's almost $4 million in savings. That's not too shabby. That might be like, I'm going to slide some math across the desk. How about a raise? Yeah, almost $4 million savings there. So the math shows that if you write your unit tests, you're going to be reducing the number of bugs in your code, and you're going to be doing so at a great cost savings to your company. Who doesn't love that? What, you don't love that? No, gotcha. Some other reasons you should write unit tests. You have a moral imperative to write good code. If you're not trying to write good code, if you're not trying to do the best you can, then the only thing I have to tell you is the next person who maintains this is hopefully a psychopath who has your address. Okay? You want to be writing good code because that's what you do. We all get up in the morning, we want to solve problems, we want to write good code. Unit testing helps us write better code. How does it help us write better code? Well, as it turns out, if you're writing unit tests and you're making meaningful unit tests, you're going to have to sit down and write code that shows you understand what your actual production code does. Let me restate that. If you're writing unit tests, you have to have a better understanding of the code you write in order to make sure that it's being tested. As you start to go down that process and learn to write unit tests, you're going to make yourself into a better and better developer. If you find something that's hard to write a unit test for, you're scratching your head going, how do I do this? You probably wrote it wrong. Probably works, but you probably wrote it, it could be written better, right? And writing unit tests will help you ferret those situations out. And another reason, and this is the one I take to managers all the time, is it takes 30% longer to write the initial code, but 2 months down the line when the tax code changes or somebody opens up a new line of business and you have to make changes to that code, going in there and changing code with a known test that says, yes, this still works, is a lot easier and a lot faster. You're not worrying about breaking something in production on your next deploy if you can still run the unit tests and all the unit tests pass. That's not to say you're not going to have to rewrite some of those unit tests or add additional unit tests as you refactor your code. Only that when you go to deploy, you have, I'm not going to be called at 9:30 at night on a Friday by the operations engineers who are mad that I broke something, right? So what do I mean by writing useful unit tests? I call them useful or meaningful. We're going to talk about a useful unit test is a test with asserts. If you don't have an assert in your unit test, you should have a long talk with HR. Okay? You're going to do some positive unit testing. You're going to do some negative unit testing. Positive unit test example is you're going to give a unit of code, you're going to give it good inputs, and you're going to expect a good output. Those are the easy ones. 2 + 2 = 4. The harder ones come in the negative unit test. So you're going to say, I'm going to give you some bad information. I'm going to ask you to divide by 0. And I want to make sure that the code is going to handle that properly and not blow up in my face. I don't want to hose the database because I divided by 0 in a controller somewhere. That's an extreme example, but you get the idea. Okay? So we've got some little examples here. Here's what a positive unit test workflow looks like. We're going to create some test data. This is specific to Apex, by the way. When we create our test data, we're creating it because we can't guarantee that we're going to have the same records in different orgs. So if you're always looking up John Smith and his contact in an org, you better make sure that John Smith exists in your development org, your QA org, and your production org. It's much better to skip that and just create your own test data every time the test is run. Create that test data, get that in the database, then you call start test. Start test resets all of your governor limits as you're doing your testing. See that you're not hitting a governor limit because you're doing all of these database inserts for your data before you actually run your code. Don't forget to run start test. Then you're going to execute your code. That's the easiest part. When you get done executing your code, stop the test, and then you're going to make some asserts. So in our 2 + 2 = 4 example, we're going to pass in some test data 2 and 2. We're going to execute that add method, and we're going to set the return of that method to a variable. We're going to call it our answer. Our answer is 2 + 2 in the add method. We're going to then say system.assert answer equals 4. Right. Does that make sense? I need nods. Need some nods. All right. Got some nods over here. Got some nods over here. Back in the back row, not so much. Okay. We'll talk later. Now let's look at our what that actually. Here's a code example. Okay. Totally made up code, but this is the positive unit test. We've got our 2 integers data. We're going to call our start test. We're going to call our add method. we're going to look at we're going to look at the variable z and say that we expect it to be 4. Okay? Negative unit tests. We're going to say create some test data. We're going to call start test. We're going to define a Boolean variable. Okay? That Boolean variable is going to say whether or not we caught the proper exception. In negative testing, you're always looking for catching the proper exception. We're going to do a try-catch block, and we're going to catch a specific exception. So if we don't catch a divide by 0 exception, we know that something else went wrong. It's not the exception we're looking for. We're still going to execute our code, and we're going to assert that if we have that Boolean equals true, that we caught the right exception. We can also look at that exception variable to look at error messages that are coming out of it, etc. So let's look at some code here. We've got our x and y, our data we're going to set our Boolean to false. We're going to start our test. We're going to say divide x and y, and we're going to specifically catch a divide by 0 exception. If we do catch that particular type of exception, our Boolean becomes true. So when we get down to our asserts, the bottom, we can say system assert, this is true. Does that make sense? Nods? Nods? Okay. All right. With that, we've got a few minutes left for some questions and answers. I will occasionally, ask you questions, maybe nods, maybe some nods, but feel free to, hit me with questions. Anybody? In writing unit tests? Great. So she just asked the question, and this is one of my favorites. As an admin who with no development experience, where do I start? Right? There are a lot of answers to that question, and I'm not entirely sure any of them are wrong. Right? The thing about writing code, and if you're a developer, you can give me an amen on this one. You got to keep practicing it. You got to keep doing it. So pick a problem that you think you can solve in code, and learn to write the apex for it. Once you've learned to write the apex for it, learn to write the tests for it. Right? I've given you the model. Good. Create your data, start tests, etc. Where to start writing apex? Where to start learning apex? There's this thing called Trailhead, and they've got a basic and an advanced apex thing. If you have no development experience whatsoever, I like learning in a classroom. I'm good at learning in a classroom. If I didn't have any development experience whatsoever, Trailhead would be a good place to start, but I would also want somebody I could ask questions to. So I would look at like a local community college. Is there a basic development course that I can go take at a community college and pester that professor with question after question? Because what language you learn there is largely irrelevant because you're going to have to learn the syntax of Apex anyway. But you're going to be learning the theory, the logical flow, all of that stuff. Does that feel like I hit your question? Okay, any other questions?
You mentioned about that it doesn't really matter if you write unit tests before or after you're done, but as a newer developer, are there any advantages to writing?
That's another great question. He just asked, if you're a new developer, is there any advantage to writing tests first or second after the code? If you are just now getting to the point where you're writing code, always start writing your tests first, right? There is a huge benefit to doing the tests first. But if you've been writing Apex for years, don't worry about it. Just write the tests, right? If you're getting started, start with the tests. Because you're going to learn to assert things, and you're going to learn when you should expect certain flows and how to properly catch exceptions, etc. Okay? Other questions? Anybody over here? Anybody? I don't know what's going on with my slides. Bueller. Oh, we got one in the back here. Yes. So he's got a question about see-all data. See-all data is, it's evil. Don't do it. Okay? It used to be there were a few things you had to use see-all data for, particularly price books, if you were playing around with price books and modifying them in your unit tests. That's not true anymore. You can grab the standard price book as an Apex method as part of the test class, the test interface. Don't use CL data. CL data is another one of those things you should have a chat with HR about. Other questions? Snide remarks. Oh, we got one here. How do you write a test for something that doesn't exist? It's not written yet. It's a great question. You're going to run into compilation issues in Apex, especially if you try and call a method that doesn't exist. So when I talked earlier about how you're often switching back and forth between the unit test and the code itself, and you're going back and forth, writing tests and then writing code, then going back and forth like that, that's one of those reasons. You're going to say, okay, I got to call this method. Oh, I got to go create the method in order to save my test, in order to get the compilation to pass. So, you'll go stub out the method, public test or whatever method, return true or return an empty string, whatever your method is supposed to return. And so you've got a test that runs against zero logic that is still going to return a known thing. Does that make sense? Okay, great. I'm out of time. It's been great having you. Thank you so much for coming. I appreciate it. Y'all are awesome. I have some stickers up here if people want stickers, and I'll be right over there in front of the sound booth if you want to pester me with other questions.